Hi everyone, today we're going to take a look at a CACD solution built on Tanzu build service, VMware application catalog, and Tanzu mission control continuous delivery components. So it's going to be a very briefly, we are going to run through the slides and actually look at the demo and the architecture that is used to build the solution. So Tanzu build service is an offering from VMware Tanzu, which will make use of cloud native build packs to turn application source code into OCI container images, OCI compliant container images. So the build service builds the images to modern container standards, right? And pushes it to the repository of your choosing. So, and it also has a support for multiple languages, such as Go, Java, Python, whatnot, right? All sorts of language. So it's able to, once we integrate the TBS with the Git repository, it's able to actually look into the code and say, hey, this is the application built from Go, and which will make use of cloud native build pack to build this Go application and run also. There are two images which are involved. One is to build the app and one is to run the application. So the run image would be the one which the application which is built will be placed on and then pushed to the registry. So it also has ability to scan vulnerability in the images, and it will also integrate seamlessly with any CI/CD tools. In this case, we have made use of Jenkins and GitHub Actions. And it runs Kubernetes. It runs in a cloud native way in the sense it runs natively in the Kubernetes with the help of KPAC. And which is easy to orchestrate and manage the lifecycle of image building. And the second component would be VMware application catalog, which is nothing but the Bitnami catalog, which gives us an option of building a prepackaged or trusted applications, and which can be maintained and verifiably tested for use in production environment. And once the images are built with VAC, they're pushed to the repository. In our case, we are making use of Azure so that it can talk to Azure registry and push the images. As long as you have a repo which the VAC can push images to, it can take care of it. And it also has a self-service portal wherein we can build our images and push those images. And we can customize our images by selecting the base operating system and what components and the library that needs to be included in the images, or make use of already available catalog. And Tanzu mission control continuous delivery is a part of Tanzu mission control. So it helps us to, once we enable continuous delivery in Tanzu mission control, it deploys a Flux CD in the Kubernetes cluster, which helps us to synchronize our Kubernetes cluster continuously with the given Git repository. So the Git acts as a single source of truth. And to conclude, we have streamlined and automated application deployment and delivery. So with the help of TBS, we will be able to automate build and packaging of our applications. And VMware application catalog and Flux CD, with the help of them, we can automate the deployment and management of these applications. So obviously this increases your security and compliance, because we can make sure that the images which are built are very secure, scanned, signed with a reliable source. In this case, TBS and VAC. And the Flux CD also makes sure that we have a single source of truth, and it can also enforce policies and approvals in Git. Or I can, if I am a platform engineer or ops personnel, I can actually create pull requests for even the infrastructure code and get it approved, and then push those changes to the Git, and that will be deployed through the Flux CD. So that will definitely increase the security, efficiency, scalability, everything. And increased efficiency is because we are actually triggering an automated build, and organizations can reduce time and effort required to manage and deploy applications, while also improving the security and compliance. Right. And the better visibility is because these integration tools will allow organization to have a centralized view of the entire application development to delivery process, a complete path to production, and help them to better understand and optimize their processes. So collaboration, again, coming back to the VAC and TBS, and even the Flux CD, wherein we can collaborate even the infrastructure and make sure we deliver the infrastructure which is in the Git repository, which the entire infrastructure is represented in a Git, and that stays as a single source of truth, and whatever is in the Git will be synchronized to your Kubernetes cluster. And the tools and the platforms that we make use for today's demo would be obviously vSphere software-defined data center, and we're making use of TKGM, Tanzu, Kubernetes Grid, multi-cloud, 3 clusters, one for Harbor, one for building, and for running the application. We're making use of 2 different registries, Harbor and Azure, and we are making use of application catalog and build service, and Tanzu mission control, continuous delivery as well. So we have 2 Git repositories, one for source code. We'll be building a Java application, testing it, and building an image and pushing it to the registry and running the same. And we have one more Git repo for our Flux CD for Kubernetes manifests. And we are making use of 2 CI/CD tools here. One is GitHub for continuous integration or testing, and the other would be Jenkins for continuous delivery to build this manifest change and push the changes to the GitOps repo that we are making use of. And we are using Octant as a UI. It's completely optional whether you would like to use it or not. So let's go to the demo. So this is the architecture which would be realized, and this is a workflow which we're trying to achieve today. So before starting this process, the developer or an ops guy would obviously build his application in VMware application catalog, and that will take care of pushing. Once the applications are built, that is pushed to a repository. In our case, we are making use of Azure. And we'll come to how Harbor replicates this repository and have these images available locally in our cluster. So coming to the developer flow, so developer need not be bothered about anything else here at all. He just has to concentrate on, writing the code and committing the code to the Git. And after that, CI/CD flow kicks in. So in our case, we have, for this demo, we have 3 branches. Obviously, I would be working on a dev branch, wherein I would push the code to GitHub. So we're making use of GitHub Actions to actually, it's not a poll. Actually, once there is a push, this is, in this case, we can have a CI/CD tool locally deployed, and that can poll the Git repo and poll if there are any changes here. But in our case, for this demo, we are making use of GitHub Actions, which will on push, as soon as we push the code to the GitHub, the pipeline kicks in here and runs some tests on our application, and then merges the code to the release branch. And this release branch is continuously being monitored by Tanzu build service. Once there is a new commit in the release branch, it pulls the application code, builds the image, and pushes it to our Harbor registry. And once the image is built, of course, Tanzu build service builds the image with the help of Cloud Native build packs, and then pushes it to Harbor registry. Once the images are available in Harbor, so we have a webhook notification that notifies our Jenkins, which will actually kick in a pipeline. And the pipeline actually, the OCI registry, the Harbor, with the help of the JSON payload, it will also send the image tag, which is being recently pushed to Jenkins. And the Jenkins will grab that image tag and clone the GitOps repository, replace it, update the image, and then push it back to the GitOps repo. So this repo is continuously being monitored by Flux CD, which is installed by TMC. And once there are changes in this Git repo, the Flux CD will take over and it deploys it in our Kubernetes cluster. So coming back to the replication one, we have a feature to replicate the images from any given registry in Harbor. So once we have this images being pushed from VMware application catalog, that is being actually replicated to the Harbor registry. And to introduce you to tools, these are the two Git repositories which I would be leveraging to, this is the code repo. And this is the GitOps repository, wherein we have customized and respective Kubernetes manifests. And this is the code repository we'd be using to interact with and push your code. And the other tools we are going to take a look at would be VMware application catalog. This is where we are going to build our applications, our images. In our case, we are making use of MySQL. So once we build this application image or a container image, we will be pushing it to a registry. So we have an Azure registry, which is added here. And once the images are built, it's going to be pushed to the Azure registry. If you look at the details, the tests which are being performed, you can have all sorts of reports for this particular image. For instance, I can have a look at a vulnerability scan, or let's say I would want to take a look at a virus scan on this particular image, right? So I can take a look at the logs and say, what are all the scans that have been performed and what is the status of it. Right. And once the images are built here, so we will have it available in our Azure registry, which has 3 images. You can see we have built Java, MySQL, and Redis, and all are available in this registry. And coming back to the environment, we have vSphere STDC, obviously. On top of that, we have 3 Tanzu clusters which are deployed, 1 management cluster and 3 workload cluster. So this is the workload cluster 1, wherein we have a Harbor running. That is our internal image registry. And workload 2 is where we will have or TBS, Tanzu build service running, where the images are being built and pushed. And workload 3 is where it's a run cluster, as explained in this image. There are 3 different clusters. So one is for running your Harbor or other services. One is for building your images, and the other one is to deploy and run the image to our application. So Harbor, TBS, and cluster to run our application. And this is the Harbor, what we have. So the images that are being replicated, we have set up a replication that will replicate from the image registry, that is the Azure registry. So right now, if you see, that's been replicated, and I have set up a manual replication wherein we pull. I don't want to sync up every then and now, so I've just pulled twice from the Azure registry, and the images that are built are pushed to images that are pulled from Azure registry are pushed to application catalog namespace or a project. So here are the images what we have, and we have a project for application images. This is where the Tanzu build service will push the images after the images are being built. And for this project, we also have a webhook. If there is a push event to this registry, we will send out a webhook to our Jenkins, which will trigger the Jenkins pipeline. So just to have a look at Jenkins. So this is our application, wherein this is what we'll be doing is to change this message, right? And we have Jenkins pipeline, wherein we have configured a Jenkins file, which will take care of building, and which will take care of pushing the images to the Kubernetes manifest to the GitOps repo, as explained earlier. Right. So this is the pipeline script. And coming back to our Octant, which is our Kubernetes cluster, we are in the cluster 1. We can go to cluster 2 and look at the pods in pet clinic release. That's where we are building our images from TBS. And that is not a pod or a deployment, that's a custom resource. So we can take a look at the builds that are being done. So right now we have 3 builds. So once we trigger, once we push the code to the Git repo, there should be a new build after the tests which are being conducted. So let me, and before going ahead and pushing the code, we also have a cluster 3, wherein we have our pods that are deployed and currently running. Right, we have a MySQL, which is obviously pulled from VAC. In our case, it's the images are being pulled from Azure to Harbor, and we are pulling it from Harbor. And these two are the 2 replicas, which are our application replicas. It's a Spring Boot application. And going back to the second cluster, we will have custom resource and have a look at the build service once we start the build process. And so here is our code, right? So all I have to do is the code is made in such a way that whatever we write here will be reflected in GitHub. In our application, right? In our Java UI. So I'm going to say, hello there. Welcome to TBS. TMC demo. And obviously, I'm in dev branch, so I'm not going to deal with main or release branches. I'm just going to push this code within the dev branch itself. So I have this code pushed to the GitHub, and we should actually have a GitHub Actions which is kicked in by now in the dev branch. So if you look at this, so we have a test with Maven. So we're running a test on this application with the help of Maven. And once the tests are run, we will push it to the release branch. So if you look at this, these are the steps which are being actually performed. So this is Java. This is downloading, I mean, maybe entire planet right now. So it'll take a couple of minutes to build here. But what I've observed is actually the build process is quite faster in the TBS, which is done locally. But in the GitHub, it'll take some time, at least 1 to 2 minutes for us to build this and run tests. So let's wait for this build to complete and the tests to complete. After that, the process is going to be pretty smooth and faster. While the application is being tested, all I had to do as a developer would be is to push my code to the Git, right? After that, the entire pipeline kicks in, and it will be handled the way I explained you in the architecture, what we have achieved. So the tests are done. You can take a look at the test result as well. Right. If you look at the tests, all the 41 tests were run, or one was skipped, but there are 0 failures, so the test passed. So after that, there are some cleanup and the job complete. After which, there is a code merge to the release branch, right? So it picked it up, it merged the dev branch to the release branch, and we should have a TBS pick that up and start building a new image here soon. So yeah, we can take a look at the image that is being built currently. So this was actually triggered by push to the release branch. And once the image is built here, it'll be pushed. The Jenkins will pick it up because once the image is pushed, the Harbor is going to send a notification to the Jenkins. Right, it'll take a couple of minutes for it to build and push. It actually takes time to reflect in the UI, but I think it succeeded. It did it in almost 50 seconds, right? And once that was done, the trigger was actually, it triggered a pipeline which made Jenkins to build to get this image tag. If there are any latent configs of a previous clone, it's going to clean it up, and then we're going to clone the Git repository from the GitOps repo, and then finally change it and commit the code. If you look at the console, you'll get an idea what's actually happened here. Sorry for. So this is the console output wherein these are the steps that were performed, right? And also you can make a note of the image I picked up. That would be 100AF, right? And it also pushed this new image to the new image stack to the Git repo. The same can be seen here as well. This is the repo which it would have pushed to, right, a minute ago. And if you look at the commit, this would be it just changed 100AF. This is the image tag that was newly captured from the webhook notification that was sent by Harbor. If you look at the commit ID, that will be 360.36A955. And we can see that in Tanzu mission control continuous delivery. So this is my cluster which has been added here. And we have a continuous delivery component here. And if you look at this, I have the sync would happen between TMC and the Git repo every 5 minutes. So give it a couple of minutes for it to actually sync this. So this should be the new commit ID that will be synced here. And that's what will be reflected in a cluster, right? But we can take a look at whether this changes are pushed to our repo. Of course, it is being pushed. And it takes a couple of minutes for this to kick in. Before that kicks in, we will have a look at we'll go to the cluster 3, which is the run cluster. And we are in Spring Boot, SE Spring Boot namespace. And of course, it doesn't have any custom resources, but we will have pods, right? So these pods are being running from 1 hour. And we can take a look at the newly, shipped pod. Okay, so it should kick in at any time now. If it doesn't, we will have to change the sync time. So it does it pretty fast. No. I should have changed it before the demo. Sorry for making you guys wait. Actually, if you see the sync interval is 5 minutes, I would have actually reduced the time. So it would have, if it is, I see it's finally picked up the changes, and it should reflect that in our cluster. right? So if you can see, there is a new pod that's being deployed, and both are in the running status. That would be 30 seconds. And we don't have any changes in our MySQL because we did not change anything. The image remains the same. That is being actually pulled from app catalog namespace that or a project. And if you look at the image that is being newly built and run, so this is the image, and this is the SHA ID of that, right? 5C100AF. So that's what we saw when the harbor sent a notification to Jenkins, and this image ID was what was picked up by Jenkins. And we have the pods running and the application running, and we can take a look at our application itself, right? So it should reflect the message what we added and pushed. Hello there, welcome to TBS and TMC demo. So this is the message we wanted to see. And to get this here, we had to, so this was the entire flow that was actually conducted. And wherein we have actually made use of continuous integration and the continuous delivery. And the developer need not have to be bothered about anything other than his code and maybe the load balancer IP of this application, right? So that's it for today. Have a good day. Thank you.